So example 2 in this series of examples. We've got holes first. Always, always, always check for holes, right? So hole first. So hole is going to be none, right? No factor I can cancel from the top and the bottom, right? And then we're going to do vertical asymptote. Take the denominator, and this is going to be x equals negative 1/3. So you don't have to show me steps for this. Horizontal asymptote, we're looking at the degree 1, so the degree 1. If the two degrees are the same, we look at the coefficients, so y equals 2/3. And again, if there's a horizontal, there can't be an oblique, so none. Put none. Actually state the word none, please. Don't leave it blank, otherwise I assume you just didn't get to it. All right. Then we're going to do domain. So I think first part of the question was A, holes, asymptotes. We've got A is the hole, B is the asymptotes. Let's do C is the domain. Okay. For the domain, you're looking for your vertical asymptote and your hole. Any restrictions? So you're looking for restrictions. There's no hole, so it's going to be just here. So x is going to be from negative infinity to negative 1/3, or from negative 1/3 to infinity. There's no other restrictions. So restrictions come from holes in there. So for the domain, look at restrictions. For domain, always look at the restrictions. No holes, no asymptotes, so we're good there. Okay, and you're either writing that in interval or set notation, right? Set notation would be written like this. So it'd be x is an element of real, and x cannot equal negative 1/3. That would be one way. Okay, so set or interval. I usually prefer interval myself, so there you go. And we're going to do the next one. We're going to do x-intercept and y-intercept. I'm just putting a line so that my notes are a little bit neater for you to read. Oops, there's my question. Okay, so x-intercept is going to be when y equals 0. So 0 equals 2x minus 4 over 3x plus 1. That just goes away, the denominator. So then 2 equals x. Again, you can do that faster. And then y-intercept is going to be f at 0, which would be 0 minus 4, 0 plus 1, so it's negative 4. Again, you can just go negative 4. So again, if you can do mental math there, that's fine. Sorry. Just showing the separation. Okay, so we got that and that. Okay, so then we've got over here positive and negative, right? So positive and negative. Sometimes for the positive and negative, I like to graph it first, and then I answer it. Okay, so I'm going to hang on for a second and then graph it. Now, I'm going to do a little rough sketch of the graph, and then I'm going to show you the check. So I'm going to do a rough sketch of the graph here. What do I have so far? I have a vertical asymptote at x is negative 3. It doesn't have to be like this. So just because it's negative 1/3, we're going to separate it out like this. So it's going to exaggerate the scale. So x is negative 1/3. And y is 2/3. So I'm going to do something like this. Move that up. Now, for here, I also have a y-intercept. I'm going to just put it in an x-intercept and a y-intercept. So I'm going to put this one in for negative 4 down here somewhere. Okay, I'm putting it in pencil in case I have to erase. And then I have a 2. So 2 like that. So you know for sure that the graph is going to do this, right? Like it has to do this. Does that make sense? Like there's no other way. I can't possibly draw it here. And it can't be in both places because it's a function, right? A function would have no overlap. So it has to be drawn there. So you already know that. So you can draw that and just double check your answer. So if you're like, you know what, I have nothing to lose here. I've already got this. So I'm going to do this, like that. And then I move my dot. So -2, -4. And that's what I mean is that sometimes I want to draw my graph and then I'll just fix the dots later. So I'll put -4. And this one here, I'll put 2. Okay. Don't add any extra curves, wiggles, any points of inflection, stuff like that. So you want it to be a smooth curve there. Okay, there's nothing else that can happen. Is there any way that I can draw the graph up here? No, because then it's not a function, is it? Because vertical line test. So don't draw anything there. So it has to be to the left of this asymptote. So is there any way I can draw the graph here?
Yes.
No, why not? No x-intercept. And if it's approaching this line, it has to go through it at some point, right? So I cannot draw it here because there's no x-intercept. If you make a little mistake with your x or y-intercept, you think it's a little mistake, it's a pretty big mistake. These lines are bothering me, right? It's a pretty big mistake. You're going to be like, oh my gosh, my x-intercept threw me off. So that's where you don't want to make a little mistake with an x-intercept. Okay, so if you go, no, I for sure double check, go, no, that definitely goes away. There's only one. I can't draw it here. So the only place you can draw it is up here like this. Okay, so that's going to be my only place I can draw it. I'm going to extend that a little bit. I know it's going to be there. So right away, you already know that it has to be here, correct? So you can write your approach from there. As x approaches -3 from the left and the right, etc., etc. I'm going to show you how to do a check, even though I already know what the answer is supposed to be. Do not do a check unless we ask you to, or if you need to. You're like looking at the graph going, I don't know which way to draw it. I actually don't know which way. And that's why I said the last 2 examples in this series of examples are ones where I made it vague, and you're going to have to do a check. Otherwise, you won't know which way to draw the graph. Okay, so here you don't have to. I'm still going to show you. So I'm going to finish the positive, negative, and then we're going to do the check. So positive here. So for positive means where is the graph above the x-axis? So it's here and here. So you do have to split it at the asymptote. Don't just go from here and then continue on. So you're going to split at the x-axis. Vertical asymptote. So x is element of -infinity to, what's that, -1/3, or from 2 to infinity. Is that okay? So there, here, and there. Not including the 2. 0 is not positive or negative, so we just don't count it. Okay, so round, round. And then here, for negative, it's anywhere below that, so it's this part here. So negative means anywhere below the axis, so it's here. So that would be x is going to be from -1/3 to 2. Good? Right? Round, round. Round brackets, round brackets. Okay. All right, I'm just doing a line. Again, I'm just trying to keep my notes neat so you can read it. Let's do the checks. The checks are not, again, necessary for this question, but I want you to understand the process when you do need it, so that way you can call upon it when you do need it. So for my vertical asymptote, I'm going to do something called a check. So I'm going to check 2 things. So yes, I do want the process done right. So we're going to do check, and we're going to check x equal. Now, typically I do a +0.1 and a -0.1. These numbers are already small. So you could do 0.01 and a -0.01 if you want. I'll accept a 0.1. For the other class, I did a 0.1 and I rounded it to -0.4. We could do 2 decimal places. You can see how small that is? I'm comparing it to 0.333. Right? So when I compare it to 0.333, I checked it. So you do a -0.1 is typically what I say, and then I also check, and I usually say a +0.1, and that's good for either end. When I did it with this one, it wasn't the greatest numbers, but I would accept it. since it's a 0.333, it's already a decimal, we should have probably done 2 decimal places and done 0.01 and 0.1. Because remember, we're talking about close to it. I'll show you the numbers that we got with the morning class, and I said I would accept it because they would do 0.1 and 0.1. It's not the greatest numbers, but it's still okay, and I'll show you why. So if I put this in, we checked negative 0.4 and negative 0.23. I don't know why we kept 2 decimal places for that one, because it was actually a little worse. So that could be 0.43. Do you want? Let's be consistent and do 0.43. I kept 2 decimal places. Okay. So when we put that in, so I'm going to show you how I do it. We're going to go F at negative 0.43. The numbers weren't great, but I accepted them because in perspective, it actually works out. So we go into and where are you subbing this in? In your F, the original F. So I'm going to go 2 times negative 0.43 bracket minus 4. I usually do the whole numerator of the rational function equals, and then I do divided by bracket, and then 3 times negative 0.43 plus 1. And I only got 16.75, which is not a big number, but remember, I'm comparing this to 0.66. So 16 is actually quite big in comparison to 0.66. Does that make sense? Like if we're doing a scientific experiment, we're talking about like a little molecule, that's a big difference. If I said that this number was 6, then it'd be nice if it got up to 60 or something, because 0.33, that's 0.66, that's quite a bit bigger, right? So I said that's actually still bigger, even though it's not a huge number compared to where my y value is on my graph, it is still 16. So if this was 0.666, 16 is way up here. So it's still telling you the same information that it's heading up, okay? If this number ended up being 0.7, you'd be like, huh, that is wrong. You haven't told me anything, right? So then you'd be like, I think I typed in something wrong. But this comparison to, so approximately 16.8, that's still a pretty big number compared to where my graph is. When I put in 0.23, let me try that again. So I'm going to go 2 times negative 0.23 equals minus 4. I finish the top equals divided by bracket 3 times negative 0.23 plus 1, close my bracket. I got negative 14.4, so approximately negative 14.4. Again, not a really big negative number, but in comparison to my graph, which is at 0.6, negative 14 is quite far down. So then it's still telling you the same information. What information is this check telling me? It's telling me that on the left side, so when I do minus, I'm on the left side of my asymptote, I'm heading up, right? I'm heading up my graph. On the right side, I'm heading down to a negative number. So I'm heading down my graph. So this is telling me my approach. So this is my check. You do not have to show me that unless we say, show your check. We want to see a check, in which case I'll give you marks. You're telling me the X value used, the Y value you got, and then you're going to say your approach. So then I'm going to say approach. Orange shows up, right? So I'm going to do approach. My approach. So if I ask you just approach, you're only giving me the approach. So you would just give me the answer. My answer would be the limit as x approaches. Now what are we approaching? The left side of my vertical asymptote here. So you go negative 1/3 to the left of my function of f of x equals. And that's telling me it's going up to a big positive number, so it went up to infinity. Okay, my approach here would be x approaches negative 1/3 from the right of the function, and that would tell me that it's heading on the right it was heading down, and look, I got a negative 14, which is telling me negative infinity. Again, it's not a huge number, but in comparison to 0.66, where my graph is very small, 14 is quite large. Okay, so one more time. This is saying left, and that's saying up. This is saying right, and that's saying down. So left, it's heading up, and right, it's heading down. That's what it's saying. Again, you don't have to show the check unless we ask you to, but if we do ask you to show, you're showing this and you're giving your conclusions. You're doing this. This is your answer. You'd be going yes, show my check, and then my conclusion. Show my check and my conclusion. If I only ask approach, then you just have to do the approach, and check is optional. Okay? Try it again for horizontal. So for my horizontal, are we good? So horizontal asymptote, we're going to do 2 checks. So we're going to check. Now remember, a horizontal is the end behavior. So horizontal is end behaviors. So we're looking at end behaviors. Okay, so end behaviors of your graph. How do I check the end behaviors of my graph? What I'm going to do is I'm going to check x equal negative 100. 100 is fine. Okay, some teachers do 1,000. 100 is good enough for the graphs we're doing if we're going to get enough of a pattern. Obviously, not obviously, but hopefully you understand. If my graph says x equals, say, negative 50, don't do 100. Like if my numbers here are really big, I wouldn't check 100, I'd check 1,000, right? So again, it's perspective, right? If my numbers, I wouldn't try 10, because again, yeah, 10's not bad. Why not do 100? But if this was, say, negative 35, negative 70, don't check 100. It's too close to it, right? It's too close. So look at the numbers. Most of our graphs, 100 and negative 100 will work, right? But obviously, if this asymptote was at 100, please don't check 100. That makes no sense. Plus, it's the asymptote, right? So always look at the numbers to see what makes sense. Kind of that idea of scale, right? So here, 100. 100 and negative 100 will be fine to check the left and the right side of my graph. What do? I do the same thing. I'm going to go f at negative 100, and I'm doing f at 100. Okay. I got approximately, so again, practice plugging in to your calculator. I got approximately 0.68. 2 decimals is fine. Don't round it too much because, and I'll show you why in a second, 0.65. You can even do 3 decimals. Don't do 10. 10 is kind of too much, but 2 would be fine. Don't do 1 decimal. How come? I'll show you right now. I need you, okay, so we okay for the numbers? Look at the graph. I'm comparing on, so remember, you're the dotted line. So I always imagine, I'm the dotted line. I'm standing here, and you're telling me if you're like, you're below me. You scared me. You came up from below me. Or if you're standing on the dotted line, you're like, oh, watch your head. You came from above me. So you're the dotted line, and I want to know if you're whoosh coming down and hitting me on the head or scaring me by coming up from below. Okay, so you're the dotted line. So if you're the dotted line, you are 2/3. You're standing at 2/3, yes? I need you to compare your number to 2/3. 2/3 in decimals is 0.66666. If you rounded this to 0.6, that's not really useful. If you rounded it to don't round it too much. Is that what I mean by don't round? If you're comparing it to 0.666, which rounds to 0.7, and you say it's 0.7, and that rounds to you've just approximated yourself out of anything useful. Right? So if you get a decimal, maybe keep 2 or 3 decimal places. Don't round it to 1. Right? Again, 1 decimal place is what we always did in grade 9. But now you got to think and go, if I round that to 1, is that going to be enough for me to compare? Let's keep 2. You can even keep 3, but not 1. See how that goes to 0.7? That's 0.7. So now you've got nothing. You really just rounded yourself into no information. Okay, so watch your rounding. You decide. I usually go 2 or 3, and again, not 1, but 2 or 3. Okay, so 2 is good enough for me because then I already knew in my head that I was comparing it, and you're going to tell me what you're going to compare. So no one's going to lose any form remarks. You're going to say compare it to y equals 2/3. You're telling me compare it to y equals 2/3. You're only writing this check if I ask you for it. You don't have to do it otherwise. And if you're doing it rough for yourself, you can do it rough. You're not being marked on it. Then you're going to write your approach. So that's all my check is. I look at it and I know what's my conclusion. For here, if I compare it, I know it's above. Does that make sense? It's a little bit above 0.66. And this one, a little below. 0.65 is a little below. So this is for my check. So again, we're not losing any little marks for form, right? So this is my check. You would show me my check, and then do your conclusion, which is the approach. If I don't say show me the check, this is optional, right? So then my approach would be, so if I ask you approach, you're only giving the conclusion here. So you would say the limit as x approaches. Now, how do I write this? If I want to say the left side end behavior of the graph, we know this from before at the beginning of the year, negative infinity is the left side of the graph of f of x. And here, the limit as x approaches, how do I say the right side of the graph? You'd say infinity of f of x, and then equals. Now, how do I write this again? We did this in the other example. You're going to say, I was approaching, so you're the dashed line. So imagine one more time. I'm going to move the line up, page up again. Okay, so watch with me for a second. You're the dashed line. You're standing on the dashed line. So you're comparing it to 2/3. And you're either going, oh, you almost hit me on the head, or whoa, you scared me, you came from below. So you're saying, I'm at 2/3, and you came from above me. And here I was at 2/3, and you came from below me. So that's showing me above and below. Right? So I'm standing on the line going, ah, you scared me, or ah, you scared me from above. You almost hit my head, or you scared me from below. Yes?
For the x approaches negative infinity, do you also have to put like the from above as well? Like
No, because this is not above or below. You're heading, that was my 100. I just did negative 100 and 100. So this has already got its own sign. So negative infinity, infinity already are telling me left, right. And then here is where you're telling me above or below my head. That's the dashed line, and you're saying above or below this. But this is left, right. So this part here is left, right? So that's left, and that's right. And this is above and below. So left, right, and above, below. Okay, so this is just telling me left, right, and above, below. Does that make sense? Okay, that's the worst part, just trying to check it if you have to check it, and then compare. Let's try that again. I think the next one, so I'll pause this. Any other questions?